Okay, so number 1 talks about simplifying. Okay, and when we simplify, we have to remember that we're going to distribute and then combine like terms. So the first thing I'm going to do here is recognize what's on the outside of that parenthesis. And on the outside of that parenthesis, we have a positive 2. So that's what we're going to distribute. And we're going to distribute that 5 times. Every single term inside of that parenthesis must get multiplied by 2. So 2 times 2x cubed would be 4x cubed. 2 times x squared would be 2x squared. 2 times a negative 4 would be a negative 8. 2 times an x squared again would be 2x squared. And then 2 times a negative 10 would be a negative 20. So now that we've distributed, we're going to work on now combining like terms. And when we combine like terms, we look for terms with the same base and exponent. And I always like to start from highest to lowest. So first we have this 4x cubed. So we're going to take that and we're going to bring it down and we're just going to rewrite it because there's no other term with an x cubed in it. After that, we're going to look to see what the next highest exponent is. And in this case, it's an x squared. So I see an x squared here and an x squared here. So now when you add these, 2 plus 2 would be another 4x squared. Okay, and then lastly, we have this negative 8 and negative 20 that we can add together to get negative 28. Okay, number 2 talks about factoring, and we have x squared minus 7x minus 30, and when we look at that, we have 1, 2, 3 terms. And when we see 3 terms and we are asked to factor, we are going to use our AM method. It's the only kind of factoring we can do with 3 terms. When we do the AM method, we need to take our last term, our negative 30, and we need to come up with numbers that multiply to give us 30. Now, the first term we're always going to write is 1 times that number. So I'm going to write 1 times 30. And then what I like to do is just take the calculator and divide. So when you do that, you're doing 30, and then you're going to work your way through the numbers. So divided by 2, and you're going to see if you get a nice whole number, and you do. So we're going to write 2 times 15. Then you're going to do 30 divided by 3. And you get a nice whole number, 10. So we're going to write that. Then you're going to do 30 divided by 4, and you're going to see you get a decimal. So we are not going to write 4 and 7.5. Then we're going to do 30 divided by 5, which we get 6. So we're going to write that one down also. And then we can stop because if I went on to the next number, I'd be at 6. So now we're going to figure out our signs because we do have to figure out what's positive, what's negative. So I need to multiply to a negative 30, which means my signs, in order for that to happen, have to be different, meaning one has to be positive and one has to be negative. Because I'm adding to a negative 7, that tells me that my larger number is going to be negative. So when I look at my list here, I'm going to make the bigger numbers of the pairs negative. Now, out of this list only, I'm looking for the one that's going to add to get me a negative 7. So again, go to your calculator and try them. 1 plus negative 30 is negative 29. No good. 2 plus a negative 15 is negative 13. No good. So far, these two do not work. 3 plus a negative 10 works. So that's going to be the pair that I want to use. So when I write this out, okay, my x squared just becomes x and x. And then my plus 5, I'm using the wrong terms. Hold on. I'm taking the wrong ones here. So I'm using the plus 3 and the negative 10. And those are my two factors broken down that when if I did the box method to this, it would go back to the original problem. Okay, number 3 says Michael borrows money from his uncle who's charging him simple interest using the formula I equals PRT. To figure out what the time t is, Michael rearranges the formula to find t. His new formula is t equals. So we want to take the original formula, I equals PRT, and our goal is to solve for t. We want to get this t by itself. So the way we do this is we do use inverse or opposite operations. So we first have to figure out how are the p, r, and the t stuck together? What operations in between them? So because we don't physically see anything, there is technically multiplication in between. And if I want to undo multiplication, I'm going to use division. So when I divide by what I don't want, which is the p and the r, and I cancel these, I'm now left with just t equals, and I cannot actually do anything on the left side. So I'm just rewriting exactly what I had. I divided by p r over r. And that would be what t is equal to. Okay, number 4 is just a basic two-step equation. So we're going to draw our line down, and then we are going to use inverse operations and kind of solve for our x. So I want to get rid of that negative 12, so I'm going to add 12 to both sides first. They'll cancel here because they're opposites, and I'm left with 2x equals 0 plus 12 is 12. Now I want to get that x alone, so I'm going to divide out that 2 to get rid of it. And now x is by itself, and I get that x is equal to 6. Okay, the next question is kind of a review question. We haven't talked about it in a while, but it is asking what property is being shown. So if I look at that first example there, that first one, you'll see that there's a plus 5 at the end of the parenthesis, and then on the other side of the equal sign, it changes and moves to the front. So what happened here is that we changed order, right? And when we change order, we have the commutative property. And the way I remember this one is CO, change order. So CO, change order, commutative starts with that. The next one, you're adding 0, right? You're adding 0, and you're basically keeping the original the same. The identity is not changing. So this one is actually the identity property of addition. You're adding 0, and you're keeping the identity of the initial term the same. Okay, number 4 we use quite often when we're solving, right? We're taking the parentheses, and then they're gone on the other side. So we're taking that 5 and we're distributing it. And in doing what I just did, I said the property, right? The distributive property is what we just showed. Okay, and then the last one, if you notice, is what's happening in there is that my parentheses are initially around my 3x and my 4, and then they shift and they move to the 4 and the 5. The order of my numbers stay the same, 3x, 4, 5, 3x, 4, 5. It's just that in this one, my grouping changed. So my grouping changed, which is the associative, who they associate with changes. Okay, and again, I said it during class, but this is the one I would like you guys to know for the test and be able to identify. So you want to make sure you can pick out an example of the associative property. Okay, number 6 says Kyle's soccer team is purchasing jerseys. The company charges $300 for a one-time setup fee and $20 for each printed jersey. Write an expression, which means no equal sign, just an expression that represents the total cost of X number of jerseys for the team. So again, they are telling us to use X for jerseys. They're telling us that jerseys are $20 to be printed. So those two terms, because they both represent jerseys, have to go together in my expression. So 20 and X go together in my expression. My 300, I have to pay them just to kind of get them to even consider making my jersey. So I'm going to add that 300 to my expression, and it just kind of sits there and doesn't get added to, multiplied by anything. So that would be an expression that represents the total cost for X jerseys. Okay, number 7 we did last Friday. It says to write a let statement for 3 consecutive even integers, and then it also says to write it for 3 consecutive odd. So even or odd numbers, so for even numbers, we have numbers like 2, 4, 6, right? Those are even. So what it's asking for is if I don't know my first term, right? I'm not sure what it is yet. I want to know, well, that first term is my 2 in this example here. So if I want to get from 2 to 4, I'm technically adding 2. So I'm taking my X, right? And I'm adding 2 to it to get to the next integer. If I keep going, to get from 2 to 6, I'm technically adding 4. So I'm taking X and I'm adding 4 to it. Altogether, these represent 3 consecutive even numbers. Okay, and the same thing would kind of go for odd. So if I take 3 odd numbers that are next consecutive, it would be like 1, 3, and 5, right? So again, if I don't know the first one, I want to know how do I get from 1 to the next. So from 1 to 3, it's the same pattern. I'm adding 2. So I'm taking that first term and I'm adding 2 to it. To get to the next term, to go from 1 to 5, I'm adding 4 there. So again, I'm starting with X and then I'm adding 4. So this would be the let statement for 3 consecutive odd integers. Notice, doesn't matter if I say even or odd, they're the exact same thing. You're still always skipping 2. Okay, number 8 is just a solving an equation question. So we're going to draw our line down the equal sign. And we are going to get our variable on one side and our numbers on the other. So if I'm looking at this, I want to take that negative 20c and I want to combine it with my negative 5c. And again, there's many ways to do this first step. As long as you follow through, it's fine. So I'm going to take the negative 20c because it's smaller than negative 5c, and I'm going to add it to both sides. So I'm going to add 20c to both sides of this equation. So a negative and a positive 20c, they cancel each other out on this side, leaving me with a negative 5 equals, now negative 5c plus 20c is going to be 15c, and then my plus 10 comes down. Okay, now I'm almost at the point where c is by itself on that one side, but I still have to get kind of that plus 10 away. So I'm going to subtract 10 on both sides now. These will cancel, and negative 5 and negative 10, when I add those up, I'm going to get negative 15, which is equal to a 15c. And now to solve for c and get it alone, finally, I'm just going to divide by 15. So I end up with c is equal to negative 1. So yes, it involved a little more step than the 2-step equations. But again, your primary goal is to get your variable on one side and your numbers on the other. Okay, number 9 talks about finding the GCF. And I did go over how to do this in the calculator. I'm not going to write the steps down because I wrote them on the review sheet we did in class, but I am going to show you how to do it on the computer right now. So I want to know the GCF of these 3 terms. So the first thing I notice here is that all 3 of these have a common letter, right? They all share an X. So part of my GCF I know has to be X. There's nothing I can debate about that. There's an X in everything. So now when I go to my calculator, there is a feature that will find that GCF for us. So we're going to hit math. We're going to scroll over to num, and we're going to scroll down to number 9, GCD, greatest common denominator, and we're going to hit enter. So what you're going to do is put your first 2 terms in there. So we're first going to do 12, comma, 36, and close the parenthesis and hit enter. So what that just found was the GCF between 12 and 36, right? So between these 2 terms here, my GCF is 12. But I have to make sure that works with 42. So I'm going to now take the math button again, and I'm going to go over to num, and I'm going down to number 9 again, and I'm going to do the same steps, but now I'm going to use 12, and I'm going to use 42 because I want to check to see if it works. And now you notice it doesn't. So they bounce now and say, well, 12 doesn't work, but 6 does. So my overall GCF of these 3 terms is going to be 6. And I'm still going to have X because X is in all 3 of my terms. So again, if that was confusing, rewatch the video, watch me go through the steps, and it will help you. Okay, number 10 is another solving an equation question. So we're going to draw our line down the equal sign. And in this case, we have parentheses. So we're going to distribute first. So I'm going to take that 4 and I'm going to distribute it to both the terms in the parenthesis. So 4 times x is 4x. And 4 times negative 2 is negative 8. Everything else in this equation will just drop down. Okay, and I'm a big step follower. So at this point, when I look at something like this, I'm going to take my smaller variable, and that's what I'm going to move. So I have a 3x and a 4x. 3 is smaller than 4. So I'm going to take it and I'm going to subtract it to the other side. So 3 minus 3 cancels. My 4 comes down. My equals comes down. 4 minus 3 is 1x or just x. I don't have to write the 1 in the front of it. My minus 8 comes down. Okay, my last and final step to get that x by itself is now I'm going to add 8 to both sides. The 8s will cancel. Now I have that x is equal to 4 plus 8, which is 12. So I'll write this nice and big over here. X is equal to 12. Okay. So number 11 starts our part 2s. So this would be ones where you'd have to show your work when you're taking the test. So for this one, it's asking you to write the expression 3x plus 4x squared, parentheses 2x plus 4 plus 6x squared minus 8x as a polynomial in standard form. So they just want us to simplify this as much as we can and make sure we're written from highest to lowest. So I'm going to distribute first, and I'm going to take this 4x squared and I'm going to multiply it to both my terms in here. So 4x squared times 2x would be 8x cubed because remember we're adding the exponents here. And 4x squared times 4 would be 16x squared. Now, all that answer is what I get when I distribute. I still have a 3x in front of that, a 6x squared behind it, and a minus 8x as well. So now I'm going to look to combine things. So I'm starting with my highest exponent because it says to put it in standard form. So I'm going to look for that x cubed first as my highest. There's nothing else with an x cubed, so we're bringing it down. After 3 would be an x squared. So I'm going to say, oh, well, I have one here, 16x squared and 6x squared, and I can add them together. 16 plus 6 would be 22 x squared. And I can combine my 3x and my negative 8x, and I can get a negative 5x. So this would be my final answer. And it's written in standard form, highest to lowest exponent, and all my terms are combined. Okay, number 12 is another solving an equation question. So we're drawing that line down the equal sign. We are combining if we can. We are distributing if we can. And our goal is to get the variable alone. So in this particular case, I don't have parentheses, but I do have like terms on the same side of that line. So I have a negative 4x and a negative 6x. Those are like terms, and they're on the same side of the equal sign. So it's almost like you're just simplifying it so far. So negative 4 and negative 10, and negative 6 is negative 10. I'm giving you the answer. So negative 10x, I'm bringing down that plus 6, the equals, and the 26. Now it's a two-step equation, which we did when we were, I think it was example 4. So we're going to subtract 6 from both sides. We get negative 10x is equal to 20, and then we're just dividing by negative 10. So x is equal to negative 2. Okay, so again, make sure you're combining, distributing, and then you're working your way to that two-step equation and solving for the variable. Okay, number 13 is the word problems that we've been working on, and these are the smaller, larger ones, this first one. So in the first one, we have the larger of two numbers is 5 more than the smaller. So I know that there's two sets of numbers here. I have a smaller and I have a larger. And I told you guys, whatever's mentioned last in that first sentence is always going to be your x. So my smaller number is my x. My larger number is 5 more than the smaller. So I'm taking the smaller number x and I'm just switching and adding the 5 to that. Notice I drew the switch symbol, so I have to make the switch. Now I'm going to take the words from the second sentence and translate it to make my equation. So it says twice, which means 2 times, the larger. Well, the larger number is x plus 5. Then it says is, which means equals, 40, which is just a number. More means plus. Than is a switch word. The smaller, well, my smaller number is just x. So now I'm going to take that equation that I just translated and rewrite it. So on the left side, I have 2 parentheses, x plus 5 equals, and now I have a switch word, so I'm going to put the x first and then the plus 40. Okay, well, now we can solve this. It's just a regular equation. So I see parentheses first, I'm going to distribute. So 2 times x is 2x, 2 times 5 is 10. Equals comes down, x plus 40 also comes down. Now I'm going to combine my x's. So now that my x's are on different sides of the equal sign, I have to use opposite operation. So my x, I'm going to subtract it from both sides. So it will cancel here, and 2x minus 1x is just x. My plus 10 comes down. Equals, and 40 come down. And now I have one step to get that x by itself. I'm just going to subtract my 10. So x is equal to 30. So now remember, the question asked me to find the numbers. So 2 numbers. I only have one, so the 30 is my smaller number. To get my larger number, I'm going to take 30 and I'm going to add 5. So my larger number is 35. If for full credit, guys, you have to state both, right? You're going to lose points if you don't state both numbers. Okay, number 14 ends up being another equation question because you have a proportion, and when we solve proportions, we are cross multiplying. So I'm taking the top of that first fraction, I'm putting it in parentheses because there's more than one term, and I'm going to do the same thing to the other side. Now I'm just going to take the bottom of my first fraction and multiply it by the top of my second. So it ends up looking like 2 parentheses x minus 1 equals, and now take the bottom of the second one and multiply it by the top. So 3 parentheses x minus 2. Now you just have a regular equation. So we're going to draw our line and we're going to solve this. So 2 times x, we're going to distribute here, is 2x. 2 times a negative 1 is a negative 2. Equals 3 times x is just 3x. And 3 times a negative 2 is negative 6. Now again, I'm a creature of habit, so I'm going to take that smaller x value, the 2, because 2 is smaller than 3, and I'm going to subtract it from both sides. So they will cancel here. I'm left with negative 2 is equal to, well, 3 minus 2 is just x, minus 6. Now I'm so close to getting that x by itself because I ended up with 1x. So I'm just going to take that negative 6 that's attached to my x and I'm going to add it to both sides. It'll cancel here and then I'll be left, negative 2 plus 6 is 4. And that's equal to x. Okay, and then that last one, last word problem here, it says if 3 times a number is decreased by 8, the result is the same as when 2 times the number is decreased by 2. Find the number. So here, they're only talking about one number. So I can say that x is equal to the number. They're only talking about 1 here. So when I take my words and I translate them, keep that in mind. Anytime you see a number or the number, you're going to put an x there. So this says 3 times a number is decreased by 8. So if I just take that and rewrite it, it's going to read 3x minus 8. The result is the same as that entire thing, just means equals 2 times the number again, so there's my x, decreased by 2. So that would be 2x minus 2. So now you just have an equation that we can solve. So my first step is I like to take the smaller variable. I have 3x and 2x. I'm going to move this 2x. So I'm going to subtract 2x from both sides. These will cancel. 3 minus 2 is just x, or 1x, and I don't need to put the 1 there. My minus 8 comes down, and so does my minus 2. Now again, I have one step left because I'm just going to add this 8 to both sides and end up with x is equal to 6. And I don't have to do anything else because it's only looking for one number. So that's the whole review sheet, guys, that at any point you want to go back and rewatch certain parts. Watching this is studying, so it's a good resource to use when you're studying for this test.